there may well be some activity creeping up on the horizon. Guys, stay with us through this video and we'll explain a little bit more. I'm Gene from maverickstar Observatory. Very good afternoon to you and welcome. Guys, we're looking at the TriMag data, and as you can see, the blue line in the middle of the chart, a lot of activity. You can see the frequency of the activity is strong if you compare it with all of the other archived data on the TriMag system. This is the system, I'm sure most of you follow us and already know, this is the system we use to pinpoint the exact location of the magnetic North Pole twice a month now, because of recently, over the last few months, the uptick in activity. So, on the request of many people, we've decided to do it twice a month. And of course, if things really start to pick up, we'll do it once a week. There's that. You ain't going to get this data anywhere else. This is the only public funded observatory on the entire internet that covers the magnetic North Pole in the resolution that we do. That's every 3 seconds. That is one hell of a resolution. If you just look at the bottom of the chart, you'll see 96,000 odd readings have been taken in order to build this chart. So there's an incredible amount of data in there. And that's not all the data that we collect. In the raw format, there's almost, on average, 300 to 350,000 data sets. So you can imagine that's quite a lot of data. What is important is that we are knocking very, very closely on the number 14 door. And if you look on the left hand side of the chart, you can see 0 to 25. We calibrated the TriMag at 10, and we have gone to almost now 14, which means we are still tracking westerly. And it is based on the data that we collect that we're able to triangulate the exact position of the magnetic North Pole for you. And we're going to get into that a bit later on Google Earth and just show you where we are. And more importantly, I'm sure you're on the edge of your chairs right now. You want to know how long it is before we reach that theoretical 40-degree mark. Now, again, a disclaimer. I'm not saying the world's going to end if we hit the 40-degree mark or the poles reverse completely. Okay, I've never said that. That is just rumour. All right, I would never say something like that. We are just tracking for that sake of knowing what will happen when it will happen. And obviously we do know some things. We know that cosmic rays will increase. We know that cardiac arrhythmsis failure will increase as this happens. And it won't just affect human beings, it'll be across the range of all biodiversity on our planet when that happens. But there's something else before we get to opening up Google Earth and doing the pinpointing for you. There's something else I want to show you. Have a look at the magnetosphere data over the last couple of weeks. So we're still at poleshiftnews.com, coming down on the archived data, and there's our new entry there. And you can see over the last week or so there has been a sharp decline, not an abrupt decline, but you can see as well as I can that there is a decline in the magnetosphere readings. So with that, guys, I want to now show you where the latest position is and tell you roughly how long we have before we surpass that mark or actually reach it. Let's start with reaching it for now. So let's get on with it. Okay, so for those of you that are following us on your own Google Earth's map and you're putting the pins in, the latitude is 81 degrees 55 hours 4 minutes 44 seconds north, and the longitude is 115 degrees 11 hours 36 minutes 11 seconds east. And you can see that we have covered 3.1 miles. Now, looking at the 40-degree mark, which is not in line with the tracking of the magnetic North Pole. That's because that 40-degree mark has been on my map now for quite some time. I would be really surprised if it hit it exactly when we predicted it, but that was just a point at where it was measured to that point where the 40 degrees mark is, and you can see how far we are away. Traveling at 3.1 miles in just around half a month is pretty surprising. It is migrating now the faster it has ever migrated. Let's just bring that to the table and think about that for a moment, because I don't think it's by any coincidence that we are reaching this point now, or roundabouts that point where it was predicted 2.5 years ago, was it, something like that, that we would see some activity. Well, in the last few months now we have seen some pretty strange activity. If you remember, it stopped. That's where our green cursor is, when it went backwards for the first time we'd ever recorded it going backwards in the month, and then, or in the half month, and then going forwards again and stopping, and then getting to this point where it would have already passed it if it hadn't have done that. And I really don't think there's any coincidence in the fact that when we zoom out, and I know the video, in fact I'm going to stop the video then when I start it, because we're going to zoom out and we can see where we are in relationship to the the North Atlantic Ridge, because I think that adds something to do with the behaviour. Just as we was passing the North Atlantic Ridge with the positioning of the magnetic North Pole, we started to see some crazy activity. Anyhow, before I do zoom out, let's just work out how much distance there is, and there we can work out what time's left, because I'm sure you'll agree and already know there's not a lot before we pass or reach that 40-degree mark at least. Let's do that. Well, as you can see, there is 3.3 miles to the centre of the 40-degree mark. So we have, on this month, around the 17th or the 18th, arrived at 40 degrees. Why is it important? Let me just bring up the experiment so you know why it's important. So in case you're wondering what all this is about, it's about this experiment here on the right hand side, top right hand side. And what you'll see is, as the magnet that's rotating goes round, it affects the compass. And I've said that there's nothing too dissimilar to what's taking place in our Earth, and I've been criticised for that, because I'm showing two components. But that is exactly what you would get if you was holding your compass, in any case, in your hand. There would be whatever is influencing it, and then there'd be the visual effect of that influence whilst you look at your compass. What you'll see is, I know the resolution on the video isn't perfect, when I upload, and that's just to save upload time on YouTube. I don't want to sit here for nearly an hour and a half while I upload it in high res. Especially even though I've got broadband, it's supposed to be quick, it still would take some time. But what you'll see is it gets to 40 degrees and then accelerates, and that's what this theoretical 40-degree mark is all about. You see the compass slowly migrate through the strong field lines, or the strong magnetic field lines, but when it reaches 40 degrees, that is the barrier between the strong field lines, which enables a slow migrating pole, which we've witnessed for the last 120 years, turn into a fast migrating pole, which is what we anticipate may happen. And I'm not saying it's going to happen, on the 17th when we hit that spot, but that is the critical spot, 40 degrees. You can see it repeated many times in this experiment. It happens every time. And that's because, the field lines are moving from the strong to the weak. And when they're in the weak field lines, the dipole or the magnetic pole doesn't hang around. That's what we're suggesting. It doesn't mean that when we get to the 17th of this month, the crack of midnight, we're all dropped down dead. That's not what it means. It just means that from that point on, we should start to see some activity. I think I've already proved myself right in any case, because earlier this year, if you remember, when we started to really notice changes for the very first time in the recorded history of the geomagnetic North Pole migration, it was at that point that universities started to come out and say that there had been signs of changes in the core activity of our planet. And that is exactly what we would expect at this point in time. Now, we did leave the mid-Atlantic ridge recently, in the last month or so. We've crossed that ridge, and now we are still tracking west towards central Russia. For now, that is where the pole is heading, guys. I can guarantee you that. I can put money on that, and you can take it to the bank. It is going towards central Russia at the moment. The safe magnetic North Pole has left the Antarctic Peninsula and is heading in the direction of South Australia. Now, some people say, they're going to meet, and it's not going to happen. And I'll tell you why it's not going to happen, because if you look at where the South Atlantic anomaly is right now, that is what's going to stop them two poles meeting. We are in the territory right now of the unknown. It's never been recorded, even if it was an excursion 12,000 years ago. It was never recorded in any case what we've got to expect. We're just here right now doing our best to record it, and at a super high resolution, so that that data can be presented to other organisations after this event has taken place. That's the only reason why we measured it at the resolution that we did of 3 seconds taking a reading. So here we are, we're in the month, and she is tracking at the fastest rate she ever has. I'm talking obviously about the magnetic North Pole. We have to wait and see, and it'll be an interesting month no matter what happens in any case, for the reason that it is migrating faster now than it ever has done. Guys, don't leave the video yet, because we want to mention the link. The only thing that keeps our observatory going and keeps the information flowing to you guys is a little bit of support from just a few of you every time I mention it, and we need to do more about that, because it isn't enough. We don't have half the equipment we should have in the field out there now monitoring this. As things pick up, I'm thinking you'll agree on that with me. We need more equipment, we need more muon detectors, we need to measure the inbound radiation now more than ever. And there is other fields of work which we can do on there, but we can only talk about them because we simply just don't have the funding for it. And I know this, there is more than enough people that view this information every month that could make a big difference, that by choice they're not. Guys, you need to get off your chair. You need to be proactive here. This is a once in a lifetime event, and you, your families, all your loved ones are going through it now. And I'm not going to go on anymore. The link is down there. You shouldn't need any encouragement to support this. We are against all the other organisations, and we have been ridiculed for that. It's time my little army out there started stepping up to the line. Guys, links down there. And I'll say what I usually do. You take care of your loved ones. As always, bye for now.